We look at next example. Use the Rydberg equation to calculate the wavelength of spectral line of hydrogen atom. When electron drops from fourth orbit to first orbit, identify the series the line would be formed. So kita nak belajar, mula-mula kita nak belajar lukis energy level diagram lah, because it's quite some time already since our last video. We learned about drawing energy level diagram. Okay, axis Y, that is our energy or potential energy again. Then we begin with n equals to 1, n equals to 2, sorry, n equals to 3, n equals to 4, n equals to 5, let's say n equals to infinity. Sorry. Contoh, n equals to infinity. Right, we draw like this. So the question are talking about from fourth orbit to the first orbit. Okay, jadi kita buat fourth orbit to the first orbit. Fourth orbit to the first orbit. Fourth orbit to the first orbit. And there drops. Okay, drops means emission spectrum. So energy will be emitted lah ataupun release, kan? Emitted ataupun release. So they want to know the wavelength. They want to know the wavelength. Jadi kita kira lah wavelength. 1 over lambda equals to RH 1 over n1 squared minus 1 over n2 squared, whereby n1 smaller than n2. 1 over wavelength 1.097 times 10 to power 7. N1 smaller than N2, so N1 is 1, N2 is 4. Therefore, wavelength equals to, we can give in meter or nanometer because soalan tak sebut. They never mention in meter or nanometer, so we can give both or either one, you can choose. So we calculate. So I get 9.723 times 10 to power minus 38 meter. Let me confirm. Yeah, 9.72 times 10 to the power minus 3 meter. So if I change it to nanometer, 97.23 nanometer. Okay. So in this question, what we learn is, we learn about how to draw energy level diagram and the transition, and also to calculate the wavelength. The last question is, identify the series. So if you see the fallback, that is n equals to 1, that was the ground state or the lowest energy level. That means this is Lyman series. That's all. Thank you.